Let me shift gears a little bit here, and this will be directed to you, Dr. Mason, at Los Alamos. Talking a lot about what we're going to do to move to this renewable energy economy, what that's going to mean. We talk a lot about our supply chain vulnerability. We've really seen that spotlight shown in a COVID-related world when it comes to the medical side. But we also know that when it comes to energy, if we don't have these critical minerals, we are at a competitive disadvantage. We can't be in a position where we rely on China. We can't be in a position where we're relying on other countries who have lower environmental standards and lower standards when it comes to human rights and worker safety. So how we are able to access our resources, our critical minerals, and do so in a way that acknowledges the environmental stewardship that must come with it, but also in a way that we're looking to greatly reduce the emissions. So I would ask if you can share with me anything that our national labs are doing, whether it's through technology development or investigating new approaches to production that will help support more responsible development of our domestic mineral resources. Part of the conversation that we had yesterday, I was reminded that I'd visited a site in Sweden, Kiruna, Sweden, as part of the last Arctic Council meeting, several Arctic Councils ago. But the LKAB mine there is working towards getting themselves entirely removed from the fossil emissions as a significant mine there. And I don't know whether our labs are looking at any of these technologies that might help advance us when it comes to accessing our critical minerals.
Yeah, that is actually a very active area. It's certainly the general issue of supply chain vulnerabilities is one that's very much in our awareness in the NNSA labs because, of course, we have responsibilities in the nuclear deterrent that have some of those supply chain vulnerabilities. And oftentimes it does come down to access to very specific materials that have physical, chemical properties that make them well suited to certain applications. It turns out that in general, it's not that the U.S. does not have those minerals. We have them, but we have not been actively exploiting them for some time. And in many cases, and in particular, China has been very sophisticated in its approach to, leveraging their control to the current supply chain to their economic advantage. So some of the activities at the labs include looking at some of the chemical processing in order to come up with more environmentally acceptable ways of accessing those materials that may be present in small quantities. And part of the reason that the U.S. got out of that business was because of that, the environmental impacts of the processing. So alternative processing technologies and that sort of chemical separations is a core competency for many of the DOE labs. There has also been work looking at alternatives. Maybe there's a smarter, better way to do it that does not give that chokehold to others in terms of the supply chain, so there's work on alternatives. There's actually a thing called the Critical Materials Institute, which is a consortium of DOE labs, Oak Ridge is involved, Ames Lab, Idaho, as well as academic researchers and industry partners that in addition are looking at things like recycling. There's a lot of critical materials that are tossed into the trash on a pretty short time scale because they're high-tech components that may have, pretty short obsolescence times. And so if we can begin to recycle, some of the samarium, then we don't have to rely on those supply chains. And it's material science, it's chemistry, it's chemical separation. These are areas that are part of the toolkit of the Department of Energy.